Welcome everyone. We're here today to do an example problem. We're going to look at solving series circuits. By the end of this video, you should be able to take a series type circuit with resistors in it, and you should be able to solve for things like voltage, current, and resistance. So taking a look at our circuit here, this particular circuit, we have a 1.5 volt battery. We have our first resistor here is a 50 ohm resistor. We have our second resistor here. This is a 200 ohm resistor, and our third resistor here is 100 ohms. So the way I like to do this, when I say solve these circuits, basically what we're looking for here is we're looking for the individual voltages, the individual currents for every single resistor. So I want to know the voltage and the current here. I want to know the voltage and the current here, and I want to know the voltage and the current here. Now, we're going to take advantage of the fact that there's certain things in series circuits that we know to be true. So I'm going to go over to how I actually go about solving a problem like this. The first thing I do is I like to make myself a chart here, and you notice here I have it laid out, so this just reminds me of all the things that I need to find. Of course, there's voltages. We're going to find the total voltage and the individual voltages for all three resistors. We're going to find the total current and the individual currents for each resistor as well. And of course, the resistance. We're going to find the total resistance for the entire circuit, sometimes known as the equivalent resistance. We're going to find, or in this case, we actually already know these individuals. So let's start with that. Let's put in what we already know in this problem. And in this problem, we already know that this is 50 ohms, that this is 200 ohms, and that this is 100 ohms. Another piece of information we knew from our problem is that we're starting with a voltage of our battery is 1.5 volts. Now, a couple things I want to talk about here before I actually get into solving is that when we look vertically in my chart, I know that I can use things like Ohm's law vertically. So when I see two things vertically, I know that I can apply Ohm's law in this vertical sense. When I look horizontally in my chart, I know that I can apply things that I know about, currents, and I can apply things that I know about voltages. So this may not necessarily be an equation, it may be simply things that I know about circuits in that way. So let's actually look at how we're going to start this. Our first step is going to actually be to find our total resistance. So step one is finding total resistance. Now, something to note is that total resistance in a series circuit, again, this only applies for a series circuit, is I can simply add all three resistors together. So basically what I'm going to end up doing is I'm going to take 50 plus 200 plus 100. And when I take the 50 plus the 200 plus the 300, plus the 100, I'm going to end up with a total of 350 ohms. Normally I would show the math here, but I'm just limited on space to be able to do that. So next up, what again I want to look for here is I want to look for things horizontally because I want to see if I can apply anything I know about a circuit. Now I've used up this kind of horizontal row. I have nothing in this horizontal row and only one thing in this horizontal row. So I'm going to go vertically now. And I notice that vertically I have two pieces of information. I know voltage and I know resistance. This allows me to apply Ohm's law in this form. I equals V over R, and it's going to allow me to find the current. So this will be what I refer to as step 2. In this case, the voltage is 1.5 volts and the resistance is 350 ohms. When I do the math, and then divide these out, I get 0.0043. Let me write that again so it looks like a 3 amps. All right, so that's about 4.3 milliamps, but I do tend to like to use the base units here so that I get base units in the end. Now, something to note here, I've found everything vertically that I can find because I've got 2 pieces of information missing in all of these boxes, and I don't really have enough information to solve across this way. So it would appear that I'm stuck, but there is something that we need to know about a series circuit, and this is something you just need to know, and that is the current in a series circuit is the same throughout. So this number here gets transferred the whole way through our problem. Alright, so here I've transferred this number through because of the fact that we are dealing with a series circuit. We know that the current in all these is going to be the same. So this is not something I have to calculate. I've already calculated it back here, but I know that because they are the same that I can just transfer this number across here and do that. So this takes me to kind of step 4 here. Step 4, notice again vertically, as I look vertically here, I have a piece of information here and a piece of information there. And that allows me to apply Ohm's law. Let me get a different color here. That allows me to apply Ohm's law in this form, V equals IR, and allows me to find the voltage for this resistor. And in this case, the current is 0.0043, and that's multiplied by, let's see, the resistance is 50 ohms, so I'm running out of room here, 50 ohms, and that's amps here, of course. And when I do the math here, I end up with, looks like 0.215 volts. Now I'm going to apply the exact same process into this box with these 2 numbers here and here, and in this box with this number here and here. I'm not going to show that work, I'm just going to kind of show the results here of that, but certainly you should be able to get these same results. I have 0.86 volts here, and I end up with 0.43 volts in for resistor 3. Okay, so one thing that we can do here, after we've solved the problem, we can actually double check ourselves. And one thing to remember is that we need to keep in mind something with a law that kind of exists in circuits, and that's something known as Kirchhoff's voltage law. And basically what this law states is that if we sum up in a series circuits, if we look around any loop in a series circuit, which of course in this case there is only one loop, but if we sum up the voltages, this voltage right here, this voltage right here, and this voltage right here, that we're going to get the total voltage of the entire circuit, or the total voltage of the source, in this case being a battery. So one way I can check myself here using Kirchhoff's voltage law, if I add this to this and this, you will see that I will get very close to the 1.5 volts. The reason for the difference would be any kind of rounding that we've done throughout. Something else to always keep in mind here, and we noted this through the video, is that in a series circuit, a simple fact that the current is the same throughout the entire circuit. So these are 2 things that you kind of want to look for when you're solving a series circuit.